Today, we're going to have a nice break from earthquakes, fires, politics. We're going to talk about bees. Shannon Carr is the program director for the Sonoma County Beekeepers Association. She's been with the Sonoma County Beekeepers Association for 5 years, and she started out not knowing a whole lot about bees, but she sure has learned, and she's going to help us learn to love and appreciate bees. She is she's really beloved in the Beekeepers Association. They adore her. She's known for saying clever, inspirational things like, instead of saying it takes a village, she'll say it takes a colony. Get it? Okay. We couldn't have a better person to talk to us about these tiny, wonderful insects. By the end of her talk, I have a feeling that you will not only start to love bees and the honey they produce, but you will want to grow some plants in your garden that will help them out. Please welcome Shannon Carr.
Thank you. Thank you. Thank you so much. Thank you everyone for coming out here today. It is so wonderful to see so many wonderful, wonderful faces. And I can't tell you how excited I am to be here with you today. So as she mentioned, my name is Shannon Carr. I am the program director for Sonoma County Beekeepers Association. And I absolutely love working with them, with the people, with the beekeepers, and with the bees themselves. And when I first started there, I did not know a lot about bees. I stepped in knowing more about people, and I was going to be working with the beekeepers. But as I continued to work with them and learning more and more about the bees and how important and how vital they are to our very existence and how the world turns, they have become very near and dear to me. And so I am here today to talk to you a little bit about that, why they are so very important, and the life cycle, a little bit about the life cycle of the honeybee and how we can help the bees in making a better future for them and for us. Real quick, I wanted to just touch on bees versus wasps. Especially this time of the year, there's a lot of confusion between the two of them. And we get a lot of calls about bees in the yard, and it's actually wasps, more specifically yellow jackets. And they give bees a bad name a lot of the time. Um, Bees and wasps, they are cousins. They descended from the same wasp billions of years ago, but they went down two very different paths. And while the wasps are are a little bit more aggressive, this is a picture of a yellow jacket, probably. And the honeybees are more passive, and they really don't want to hurt us. Wasps went down the route of being carnivores. They eat meat, and they tend to be more aggressive towards people. But that said, they are still very essential pollinators, key elements in our ecosystem. As they eat meat, they eat other insects. We like to call them our cleanup crew. They are the reason why we don't see hundreds and thousands of dead insects all over the place, because they are cleaning up the dead bugs. So they are essential to the ecosystem, even though they are annoying and kind of the jerks of the pollinator world. Honeybees, or bees in general, are very passive. They're not aggressive. They are, in fact, vegetarians. They eat plants. More specifically, they eat the pollen and nectar that come from the flowers. And so we call them pollinators. As they go from flower to flower, gathering pollen and nectar, nectar is more of a fluid. It acts like a carb for the bees, and they carry it back to their hive in what is we call a honey stomach. They have two stomachs, honeybees do, one for processing food and one for carrying nectar. The pollen they carry back on their bodies. They have, we call them pollen sacs. They pack it on their back legs. You can see right here. I'm not used to this kind of a button. See those pollen sacs back there? They pack that pollen on those back legs. And while they're not actually sacks, they're not bags on those legs, they're using static electricity to pile and for it to cling there. The pollen will also, as they go through that flower, gather and cover their entire bodies. They have hair covering every piece of their body, including on their eyeballs. There's hair even there as well. So all of that hair collects that pollen. And when they go from flower to flower to flower, some of that pollen will fall off into the next flower that they are visiting as they are collecting pollen. So that is how those seeds within those flowers get pollinated, get fertilized, so that flower can later come back the next year as a new plant and a new flower. So flowers, our plants, and our bees have in fact evolved alongside one another, dependent upon one another. You lose one, you will lose the other. So why is this important? Why is this pollination process important? And that is because bees are in danger. And the bee population is declining right now. And this is not good. We will not survive if we lose the bees. We need them in our lives and in our world. And if we don't have them, we won't survive. 1 out of every 3 bites of food we eat is because those bees visited a flower that to get pollen and nectar. So every single apple you've eaten, orange, the citrus, the squash, cucumbers, strawberries, raspberries, blackberries, all of that is dependent upon the bees. So when you go to a grocery store and you walk into the produce section, this is probably what you're going to see, right? What do you think that looks like if we didn't have bees? Oops, I hit the wrong button. I went backwards. There we go. That's what it might look like. And actually, it's a little bit worse than this because I really think this picture created by Whole Foods is biased towards honeybees. Tomatoes are still in this picture. Bumblebees and carpenter bees pollinate tomatoes. Larger bees also pollinate citrus. So this is super, super important. If we did not have bees, we wouldn't have food. And it's not just the fruits and vegetables. A lot of our livestock eats the fruits and vegetables. So if we didn't have food to feed the livestock, we wouldn't have milk and eggs and meat in our refrigerators. So this is really important. And if we did not have our pollinators and our bees pollinating those flowers, we wouldn't have food to eat. What is another reason why plants are super, super important to our survival? If you think about it for just a second, you'll probably go back to grade school. And it did take me a long time to make this connection. I mean, I knew plants made this for us, but they also make oxygen. Plants make oxygen. They take our bad air and through photosynthesis, transform that into the good air that we breathe. So that right there, it's not just the food we eat, but the very air we breathe is dependent upon the honeybees, actually all bees, and their pollination process as they go from flower to flower. Now, most of the time when you are going to think about a bee, you're probably picturing the honeybee. And this is because we've been programmed that way. Our agricultural industry is dependent upon the honeybee. They're dependent upon it to the point that they actually truck honeybees from all over the country to California every single year. They load up billions and billions of boxes and of hives of bees onto the back of trucks and bring them from Florida and the Dakotas and from the whole Central America where they are overwintered. They put them on trucks. They bring them here. The timing is usually, gosh, I think it's late February, early March, when the almond orchards need to be pollinated. That is the first thing they do. They bring them here for the almond orchards. After about 6 weeks, when that is done, they put them back onto those trucks and now they disperse to other farms. Some of those trucks will head up north to Washington and Oregon to pollinate all of the apple orchards up there. And then a number of those trucks will head down to the Central Valley to pollinate all of the farms and vegetables and fruits that we grow here in California. So they are super, super important to the agricultural industry. And so they have drilled into us how important the honeybee is. But there are actually over 20,000 different species of bees around the world. And each one of those species is incredibly important and critical to our environment. Here in North America, there's over 4,000 different species of bees. That's 20% of the world's bees live here in North America. And in California, I think we are incredibly fortunate that we have over 1,600 different species of bees. 40% of North America's bees are native to California. So that's pretty amazing. And I think that's another really cool reason why I love living here in California. The honeybee, contrary, is not native to California. It is not native to North America. So when we speak of the native bees separate from the honeybees, that is why. We brought them here in the 1700s when we were colonizing the Americas because of how good they are at pollinating crops. They came to California in the 1850s during the gold rush, again, because of their ability to pollinate crops. So they've only been in California less than 200 years. And yet we see them everywhere. And in that short amount of time, they have become so important to our way of life. Some of the other bees that we do see here, and we see them here in Sonoma County, are the mason bees. There's leafcutter bees, bumblebees, carpenter bees, longhorned bees. There's lots and lots of different species of bees, and they are solitary. Another thing about those native bees and what makes them different from honeybees is how they live and their very social structures. The biggest difference, as I just mentioned, is that native bees are considered solitary. They live on their own. They nest by themselves. The females lay her eggs and then she goes off. They do not defend those eggs. She just hopes that they survive. Honeybees on the other hand, live in massive, massive colonies of 20,000 to 60,000 bees in one single hive. Because of the number of bees in that hive, they have a very complex social structure. And so right now I'm going to kind of switch gears a little bit and talk specifically about the honeybees and their way of living and their social structure and how they develop. With the honeybee, when you see that, when you see 20,000 to 60,000 bees inside that hive, that many bees, and there's only one queen bee. Right here, she's the queen. She's bigger than everybody else, and she has one job in that hive. Only one job. Her job is to lay eggs, to keep that colony going. She doesn't, a lot of people like to talk about how the queen bee, she's the boss of everything, she's in charge. In reality, with the honeybees, the queen bee is not in charge. She doesn't make a single decision. She has one job, lay eggs. The colony as a whole makes all of the decisions. It's kind of, then you also hear about hive mentality. This is the same thing with the hive of a colony of bees. They make the decisions, they guide the queen, they do what they need to do for the survival and betterment of the hive. Now, the drones right here, they're a little bit larger than the worker bee, smaller than the queen. Those are the males in the hive. They do absolutely nothing. They're useless. They can't even feed themselves. They have to be fed and they have to be caretaken. They do nothing in that. They have one job also, and that one job is to mate with a queen. So once they are old enough to start flying, they'll leave the hive. They go off and they have little parties in the sky. And we call those drone congregations, and they're just goofing off, waiting for that queen to fly by. The queen, the virgin queen, when she is about 3 days old, she will take off on her mating flight and she'll go flying off. She will mate with drones. She'll mate with, sometimes it just depends, 15 to 30 drones on that mating flight. She will return back to the hive, and the rest of her life, she is condemned to laying eggs. And that is it. Versus the drone, he died. That was it. That's the end of his life. His one and only purpose was done. He mated with the queen, and now he's gone. So sad, too bad. The women in the hive, the females, they are the worker bees. Right? Of course. They do every single thing within the hive. Everything. So from the moment they are born. So the queen laid her egg. After a couple days, it develops into a larva. It then takes about 3 weeks total, 21 days, and for that larva to develop into a bee. When she emerges and hatches, she immediately turns around and cleans the room that she just came out of. She is a cleaning bee for 1 to 3 days. The first 3 days of her life, she is cleaning. That's all she's doing. She's cleaning the comb that she came out of. She's cleaning the other comb. She is just moving around, cleaning the hive. She has a job to get done, and she is going to do that. When she's 3 days old, she's only 3 days old, She is going to start feeding the larva. She's feeding the larva, the older larva, the younger larva. She starts feeding those useless drones who need to be fed, who can't feed themselves. She's feeding the queen and taking care of her because that is very important. Without the queen, there is no future for that colony, and there's only one queen. So she is now a nurse bee, taking care of the livelihood of the hive. When she's 12 days old, she developed glands on her abdomen. Right there, you can see that. So she is now developing these glands. She is excreting wax from those glands. And that wax, she's going to take it, she's going to chew it up, spit it out, and she's going to start building honeycomb. She is now a construction bee and the architect of the hive, building comb. It takes her 12 hours for her to just excrete 8 flakes of wax. It takes 500,000 flakes to make 1 pound of wax. So in 5 days, if 1 pound of wax was going to be built in 5 days, it takes over 6,000 bees who are between the ages of 12 and 17 days old to make 1 pound of wax. They use that wax, that honeycomb that we see, for the queen. That is where she lays her eggs in. For the eggs to develop, what you see in this picture right here is larvae, young bees that will develop into a bee eventually, and the worker bees will then cap it at a certain age. So down here, these flakes of wax are capping larvae, so it will develop and eventually come out as a bee. They also use it to store food. They store pollen, nectar, and the honey they made inside that honeycomb that we see. Each one of those combs, actually those cells, we call those cells inside of there, is a perfect hexagon. That hexagon is actually Mother Nature's favorite shape. And you see it repeated a lot of times throughout different aspects of nature. But it is the most efficient shape with minimal space in between. Now, after she's 17 days old, she becomes 18 days old, and her job changes once again. She starts to leave the hive when she's 18 days old. She's never left the hive before. She's never flown. So she does not know how to fly. She is going to leave. She's going to start learning how to fly. At this point, we see a lot of figure 8 motions outside of a hive. And that is a bunch of new young bees learning how to fly, orientating themselves to their new environment. And at this point, she's going to be a guard bee. She is going to be protecting the hive. And she does this for the next 3 days. And she remembers things, actually. I've seen this happen too, where if she perceived a threat, that is a threat to that hive for 3 days. That happened to me once. They thought I was a threat, and because I broke into their hive. And for 3 days, there was one bee who thought that I was a threat. But so they do that for 18 to 21 days. She is a guard bee. When she turns 21, 22, she is now going to start leaving the hive. And she is going to leave the hive and start collecting pollen and nectar from the flowers, bringing that back to the colony. So now she is a foraging bee, collecting pollen and nectar. She will do this for the rest of her life, which is only about another 3 weeks. Bees do not have a very long life cycle. So she only lives about 43 days on average. The farther she has to fly to get food, the shorter her lifespan will be. So having lots of forage nearby is also really critical to their survival. The farther she has to fly, the harder it is on her body, the more exposure she has to chemicals, pesticides, herbicides, as well as more exposure to predators. So while humans are the number one threat to bees, they do have natural predators like the praying mantis. Um, Dragonflies are a predator for the bees. Birds are a predator to the bees. So they do have natural predators out there, and they have more chances of being caught by one of them. So now that we've heard a little bit about the life cycle of the individual bee, the colony as a hive has its own life cycle as well, because the bee you see in the spring is not the same bee you see in the summer, not the same bee you see in the fall, and not the same bee you see in the winter. So they have different behavioral patterns throughout the years as well. First of all, in the late winter, early spring, this is when the queen really starts. The earth itself is starting to warm up. The flowers are starting to bloom. The queen is going to start laying eggs a lot in the spring, early spring, late winter, in preparation for building stores for the next winter to come. She is laying over 2,000 eggs a day at this point, sometimes even up to 3,000 eggs. So in one day, if she laid 2,000 eggs in 1 week, that's 14,000 eggs. In 3 weeks, that's 14,000 new bees going to be coming out of that hive. And this is every single day. 2,000 new bees are going to be born. That is a lot of bees. They are very quickly going to fill that space inside that hive and outgrow the space that they have. So what we end up seeing a lot are what we call swarms. This is a swarm right here. So what a swarm is the natural process of that colony splitting into two new colonies. They start preparing. They're getting too full for their space. They're going to start preparing for this swarm. Again, this is the hive making this decision, not the queen. The hive will start preparing a new queen to replace the queen that they are going to take with them to find a new colony. They are going to start loading their bodies full of food and resources that will last them 3 to 5 days. That queen has not left the hive since her mating flight. She really does not know how to fly. She is not built to fly. So they put her on a diet for 3 days and stop feeding her so she can fly. And then when the new queen is about to emerge, they will leave. They will take off and fight to find a new home somewhere else. It's approximately half the hive will leave. They'll take the queen and they will go. But again, the queen can't fly very well. So they take lots and lots of breaks on this journey. And that is when we get phone calls all the time in the spring of large clouds flying down the road of bees or clusters of bees hanging from trees, on fence posts, on the side of a house, on the ground. And if they're on the ground, again, the queen can't fly. So she probably got tired and just fell to the ground, and everybody went with her. So they are trying to keep her safe as they are looking for a new home. We go out and we collect those swarms and relocate them to hives that are prepped and ready for them. On average, approximately 20% of swarms survive the swarming process and their first year. There's a lot of variables that can affect that, like if they don't find a new home in the right amount of time that they have, or they could find a home in an inappropriate location that does not sustain them. When they get to the end of their reserved food sources, they will get desperate and create that hive in a wrong spot, like the walls of a house or a barn or on the outside of a tree or a wall, and they will not survive in those sort of situations and circumstances. So our swarm team that goes out and collects these swarms, every year we have collected over 300 swarms on average every single year. I think last year was around 370. We do this for two reasons. One, it does increase their chances of survival. And the second reason is because it decreases their chances of finding a home in an inappropriate location. So now in the summer, we're moving into summer, the bees have already swarmed. They're starting new colonies, new hives somewhere else. The bees are going to be very active during this time, collecting pollen and nectar to bring back to the hive so they can start making honey. And this is for their winter food sources. They need honey to get them through winter because all the flowers have died in the fall. There's no food, no pollen, no nectar for them to eat. So that honey that we take from the beehives, we are actually stealing their winter food sources when we do that. But we are very fortunate that they tend to make more than they need, and responsible beekeepers never take more than what the bees need to get them through winter. I really particularly love these pictures, not just because all the other pictures I've shown you I've gotten from my best friend Google, but these ones I actually took in my front yard. I love artichoke plants, specifically because the bees love them. And I'll go out there, I let them go to bloom, and they just get covered in bees. And I will go out there and oftentimes just count the bee butts because they stick their heads down into there, digging for the pollen, and their butts are just wiggling up at the top. And it's super, super adorable. This other picture oh, there's a bee butt right there. But what I love the most about this picture right here is you see this guy right here? That is a teeny tiny native bee. Now, don't ask me what kind of bee it is. I don't know what kind that is, but it makes the honeybee look ginormous, doesn't it? So that is a honeybee. That is one of our natives here in Sonoma County. So as I mentioned, in the fall, the plants are starting to go dormant. Our annuals are dying off. The perennials are going dormant. This is the time of year. There's no forage. We'll start seeing bees and the wasps getting more aggressive because of this, the lack of food. They're going to try and get resources from other locations. So that is why right now everybody's cursing the yellow jackets. They are out in force, they are hungry, and the bees have plenty of food and they're going to try to steal it or take food from other resources. But the bees themselves are also starting to consolidate their hive. They need resources to get them through winter, but they can't gather it from the plants. So they're going to rely on the resources that they gathered from the last season. This means that they now need to reduce the number of mouths they are feeding in that hive. The queen is laying significantly less eggs, just enough so that they can survive the winter. The worker bees are not being replenished at the rate that they were earlier. And those drones who did not have the fortunate experience of mating with a queen, They are being kicked out of the hive right now. They're being forcibly moved. They do not participate in any way to the survival of the hive. They don't contribute. They get kicked out. And if that drone comes knocking back on the door saying, no, 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 I'm not ready to die. Please don't kick me out yet. She will rip off his wings and rip off his legs and kick him out. They are done with them. And the queen will just make new drones next year. So back to the bees in general, they are declining. We are seeing significant less bees in our environment than we were years and years and years ago. Currently, with the honeybees, they're experiencing, they call it colony collapse. On average, honeybee colonies, not all of them do make it through winter. Usually, I think the percentage is around 30 to 40% die off in the winter on average. And that's normal because if they double and triple every single year, you have to have some colonies die off. Otherwise, we would be really overpopulated with bees. When you hear the words colony collapse, that means it's significantly more than 50%, usually 70 or more or greater. And that is what happened last year. Last year, they saw the biggest colony collapse since, I think it was the 80s, when there was a massive colony collapse and they became very, very worried about the honeybee. This last year, it happened again. They are blaming it on mites. So that is a parasite that feeds off of the honeybees and how they have become resistant to treatment. But it's not just that. It is also loss of habitat across the world, across America, across the globe. It is the increased use of chemicals, pesticides, and herbicides, and other chemicals. In regards to those mites, they've been treating those mites, but instead of changing up the chemicals they've treated the mites with, now the mites have become chemical resistant. And so instead of allowing the bees to evolve in ways naturally, we tried to control it, and now the mites evolved faster than the bees, and they have become resistant to the treatments. So this is a problem, and that is something that they are trying to work on and fix. And there's lots of different ways that we can help the bees. But not just the honeybees are being affected. Our native bees are declining as well, and that is even more problematic. So we have seen a decrease in bumblebees, leafcutter bees, and mason bees, as well as other bees as well. The research, though, is not out there. Honeybees, being so dependent upon them with agriculture, they invest a lot of money in researching those honeybees, and they don't do a lot of research on our native bees. But we do know over 28% of our bumblebees are threatened. And there have been a couple of species that have gone extinct, and they are gone. Leafcutter bees, over 50% of them are threatened, and over 27% of our mason bees are being threatened right now. And they are vital to not so much the agriculture, but to life on this planet, because those native bees evolved alongside our native plants. So if you lose one, you will lose the other. So we need to make sure we do what we can to protect our bees and protect our native bees as well as our honeybees. How can we do that? By creating habitat for them, creating diverse habitat for our bees. And so when you plant a garden, lawns aren't going to do it. Lawns are fairly sterile environments, and very few critters actually can live in a lawn. But a diverse pollinator habitat has lots of different plants. So it touches on all the different species that could survive in that. They're a little messy. They're not clean and neat. And that's what nature likes. Nature is messy. and she thrives in that mess. So having plants in your habitat that bloom different times of the year, you want some that bloom in the spring, in the summer, in the fall, and even in the winter. Here in Sonoma County, we are blessed with very mild winters most of the time. So that means if we have a really warm day in January or February, those bees are going to come out of their hive and look for food. So having stuff that blooms different times of the year in your garden is vital to our ecosystem. Leaving the garbage, not garbage, but what we oftentimes call garbage, like the leaves, sticks, and twigs, is important. Those plants, those twigs are what a lot of our natives nest in. The leafcutter bees and the mason bees, they love reeds. So, in our native plants, use those stems to cart water up to the flower. So that's very soft inside. Our native bees burrow through that to lay their eggs to overwinter. A lot of our other native bees lay their eggs underground or under the leaves themselves. So that becomes protective barriers for them. And so if we don't have that top layer of leaves to protect them, they will not make it through winter and be there again in the spring. Let's see. Oh, I think that's kind of it for me right now. Do you guys have any questions for me?
Thank you, Shannon. And we'll be passing the mic around if you can. And Will, would you stand up when you ask your question?
I'd like to know with the expense of trucking bees, do they take them to Florida to do other crops in the winter, or why is that expense needed?
That's a very good question. And I am honestly not too familiar with the agricultural side of things, other than I do know that they do truck them here from all over the country. They will be used in states like Florida and Texas to pollinate things there, but they do truck the industry around the honeybees. They will load up trucks full of bees from Florida and cart them all the way across the country here to California. The number of bees that we need here for our crop is just it's just a huge amount, and it's more than what California can sustain over winter. So they do take them back to their states to overwinter them. But they also do a lot of times some companies do overwinter them here in California, and that is detrimental to our environment as well. So we see that a lot in the fall where all of a sudden 100 hives got dumped in one location. And if you think about that, if there's at least 20,000 bees in each one of those boxes, that is 2 million bees now in one spot. And there is not enough forage for those bees. They are also fed sugar water, which is like, living off of Milky Ways every single day. But so it's not really good for them, but they're also amped up on sugar water. And so they're strong. And they can tend to be a little aggressive towards the bees that live here who aren't being fed sugar water, amped up with other stuff. So it's hard on our local bees when they do that. But we do need them. So it's trying to find a balance between the agricultural industry's need for bees and protecting our own environment and ecosystems.
Considering that in the fall and winter months, much of our produce comes from Mexico. Now, what is the status there? Do they have their own, unique bee population, or how does this work?
They do. They have their unique bee population. There's also honeybees that have been introduced to Mexico. A lot of the Latin countries have they have their own kind of bees. They do also have a native bee that produces a nectar-like substance that's like honey. There's a stingless bee in Brazil that does that. There's also a stingless bee in Australia that does that. It tastes very different from our honey. They also live in significantly smaller colonies of like 50 to 100 bees. And the honey is significantly more expensive because it's a small amount that they're harvesting. But they do have bees. They have brought honeybees down there. So there's a lot of beekeeping all around the world, utilizing the extraordinary talents of the honeybees. They're utilized because they're considered universal pollinators. They can pollinate lots of different kinds of plants versus the native bees that evolved alongside the native plants and are usually considered specialists, only able to pollinate one or two types of plants.
My question is the queen bee born this way?
Born this way, what do
Yeah.
you mean? Is she born a queen?
Yes.
Oh, that's a complicated question, and that's a very
And
good
along
question.
with that, does she decide I need 120 drones? So boom, 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 here come the eggs. How does that work?
Okay, okay, that's a really good question. That's a little complicated too. So the queen, I'll just take a little bit of a step back on that too. So when she goes on her mating flight and she mates with all those drones, the sperm and the eggs are kept separate. So the colony decides what they need, if they need female bees or if they need male bees. Those cells, the honeycomb, there's two different sizes because the bees are themselves are different sizes. So they will guide her. If we need more drones in the hive, they will guide her to the larger cells. She will drop an egg into that cell and they will nurture the new bee, but there's no sperm dropped into that cell. So the males are just an egg, and it's not a fertilized egg. Now, if it's going to become a female bee, a worker bee, she will drop a egg and she'll drop some sperm into that. So all of the girls in the hive, we oftentimes refer to them as sisters, but more often than not, they're actually half sisters because she did go off and mate with 15 to 30 drones. And so you will see when you look at a picture of bees, some will look alike and some might have different variants. They could be different colors, different shapes, different sizes, just slightly. And that's because those had different dads. Now, if it's going to become a queen, they do make that decision. The hive makes that decision if they need a new queen. If they know ahead of time that they need a new queen, like they realize she's aging and she's laying less, she's slowing down, or they're preparing for a spring swarm, they will build, we call them queen cups, specific cases of wax that are significantly larger than each of those cells. They're usually hanging down from the frames, and she will drop her egg and a sperm into that queen cup. Now, the difference between the queen cup and the worker bee development, all bees are fed royal jelly for a couple of days. And then once that larva is 3 days old, they transfer that food to pollen, nectar, bee bread, other food sources. This exposes those larvae at a very young age to outside elements. So that way it's building their immune systems a little bit more. But the queen bee, she is only fed royal jelly. They never change her food source. So if it's going to be a queen, she is only fed one thing. And those extra proteins help her develop into the larger queen bee. So if they're planning ahead, they have that already set up. But there are times when an accident can happen and all of a sudden the queen is gone. Don't know why. Either she got really sick all of a sudden, maybe there was some weak comb and it fell and it landed on her. Who knows? But she's gone. The bees now have to create an emergency queen. They can do that. So they'll find a larva that's only 1 or 2 days old that has not transferred yet to the new food, and they will break down the larva all around, I'll break down the comb all around it, immediately enlarging her cell and they'll start pumping her full of royal jelly. And this is going to create a new queen to replace the old queen. Now, another thing that they do, talks about the brutal world of the bees, is in preparation and in this case, because that egg may not fully develop into a queen, they usually have 5 or 6 of these going. So they may have 5 or 6 queen cells that they've prepared already, or emergency queen cells to replace the sudden loss of a queen. But I also mentioned earlier, right, that there can only be one queen. So when that first queen hatches, she's going to make a little sound, this little pipping sound. And the new queens that haven't hatched yet, they'll answer back and they'll pip back. And she'll go over and kill every single one of them. So, yeah, there can only be one.
Wow, that's kind of hard to follow, but
It's a brutal world. I mean, it is fascinating and amazing, but it is truly brutal.
so I've been reading about what they're doing in Athens, where everyday people are putting hives on top of apartment complexes. It's very active.
Uh-huh.
And I didn't know there are things going on like that in this country.
Yeah, I've seen pictures in big cities where they will have hives on the roofs of buildings. You'll see that in San Francisco, New York, Chicago, in those not rural, those big cities, they will have hives on top, and then the bees do go around. There's gardens up there, and they do beekeeping up there.
Yeah, I just have a simple question. The
Simple
honey-
questions have the most complex answers.
Could be. All the honeybees, what you're calling honeybees, are they one species or are they different species of bees?
That is a complex question.
Okay.
There are different species within the honeybees. There's three main divisions. I mean, a lot of times they'll refer to honeybees as European bees, more specifically Italian. There's also a variant that went, and they called them evolved in Russia. So back in the time of we were all one giant continent, and then the continents split up. There was stayed in the European area, some stayed in Asia, and so we oftentimes refer to them as the Russian bees. And then there's the Africanized bees that evolved on the African continent. Because of the harsher environment of Africa, those tend to be a little more aggressive. And so that is what we see a lot of times. They did make it here to the US a couple decades or so ago. And they do have very strict beekeeping regulations in Southern California because there are Africanized bees down there. They do, like I said, they're a little bit more aggressive than the docile Italian bees. So they're honeybees. They're still derived from the same bee. They're just like, half siblings or cousins. They're in the same branch.
Hi, Janice Carmen here. I am very excited by this conversation, and I think that you are so knowledgeable, and it's so exciting to hear your experience, background, et cetera. But I really would like to know what your educational background was that led you to this, or your internships, or your country life, or whatever it was. just briefly, if you could tell us what brought you here, because you said you didn't know very much when you started, and it's so interesting and you're so dynamic. Thank you.
Very good questions. I've always been interested in sciences and in general, and I did graduate from San Francisco State after a little bit of time at Sonoma State, and and I've been involved in nonprofit, more the nonprofit world for years, and pretty much my entire life. And when this opportunity arose with Sonoma County Beekeepers Association to be their program director, I was very fortunate enough to be accepted into that. And at that moment, they really didn't care so much that my knowledge on bees was minimal. I knew a little bit. I knew they were important. I knew they were out there. But comparatively to the other beekeepers, I didn't know a whole lot about them. That wasn't what they were looking for. They weren't looking for a beekeeper. They were looking for someone who can run the programs and the administrative side and the beekeepers themselves. So I actually honestly call myself a beekeeper keeper more than a beekeeper. Um, and that I manage the people. And then through that, a lot of it has just been osmosis. You know, you're around the people all the time, you're going to pick up their knowledge. And I've learned a lot from the association in a whole and from our people, and then just research, reading, and from all the people who have visited us over the last few years.
What's the deal with bee stings? Is that like a rite of passage for bees where they go back to the hive and they say, I got 4, or how many did you get? What's the deal with bee
What's the
stings?
big deal with bee stings? Bees don't want to sting you. Actually, if they sting you, they die. They don't live. So those guard bees that are, 18 to 21 days old, they're putting their life on the line to protect their hive. So they don't. But along the same lines of the bee stings, we are finding in science that it is being that it's curing things. Like the bees themselves are apparently incredibly medicinal, and they're using bee stings to cure arthritis, to treat arthritis. And I recently saw an article about how bee stings or the venom in the stinger is treating breast cancer. So there's a lot of science behind it. But that bee, once it stings you, that stinger lodges in your skin. It is barbed. It sticks there. The bee will fly off. All of her intestines are stuck to the end of that stinger, and she flies off and dies within 100 feet of leaving you. So she honestly doesn't want to sting you, and it is a defense mechanism for them. Every single time I've been stung, it has truly been my fault because I was not paying attention to where I was going, where I was walking. I love walking around barefoot and then I step on a bee. Or when I'm going as a beekeeper and I'm going into the hive, to them, they're this teeny tiny little insect. And I'm like Godzilla ripping the roof off of their house and destroying what's inside, even though I'm being very careful. They don't know that. So they're going to defend their home, their queen, their colony, and they're going to come after me. We like to say that's aggressive behavior, but it's not. It's defensive behavior. They're defending their home as they rightfully should. Lots of hands up.
Over here.
Okay.
How much of a role, if any, does global warming play in the colony collapse?
Oh, that's a big role. Global climate change is definitely, which I think one of the things this is a personal opinion, I will state, that they like to blame the mites and treatment resistant mites because that is something easy and they hate blaming and admitting that climate change could be having a factor in this, as well as human behavior having a factor in this. But as as the weather changes in general, that definitely affects the ecosystems on microscopic levels as well. So Just using Sonoma County as an example, last year it rained like 3 months straight, and the bees didn't get to emerge and start swarming when they normally do. All the plants are delayed. This all affects the bees in general. It affects the native bees even more than it affects the honeybees, because the native bees evolved alongside their plants. They're very much on a schedule. Now, if the plants bloom later than or earlier than the bee expected, that the bee's DNA programmed it to emerge, they may not emerge at the same time as that flower went into bloom. And then that's going to cause, one, the flower won't get pollinated. So when it dies in the spring, at the end of its life cycle, it won't have seeds to come back. And that native bee, when it finally hatches, it's not going to have its food source, and it's not going to have food to survive and lay eggs for the next generation. So global warming is definitely, or I should say climate change, is definitely affecting the life cycle of our essential pollinators.
A couple questions. The first one fairly direct. You talked about the life cycle of the worker bee as being about 45 days. What's the normal life of the queen? And the other question has to do with, and probably more complex, is that the general reproductive cycle of honeybees seems to be very inbred, and most species seem to be more resilient if they're genetically diverse. Is anyone thinking about introducing, or is there a way to introduce more genetic diversity into bees?
That is a very complicated question. First of all, the queen, that one's easy. She can live to, on average these days, it's about 2 years. She used to live longer. They used to say the queen would live 3 to 5 years. But because of all of the variables in today's world, and especially exposure to chemicals, she's living on average 2, maybe 3 years. To answer your question on genetic diversity, I will be honest, I don't know a lot about that to answer that fully. But the reason why she mates with 15 to 30 drones, those drones are not from the same colony. That's why the sisters will all look different. They are all from all of the different colonies that live within like a 1 to 3 mile radius of where they're having their little party in the sky. These are all the drones, not the drones from one hive. They all go up there, swap stories, and have fun, and waiting for that queen to fly by. And so she will mate with 15 to 30 drones, and each one of those is providing different genetics to that hive that she's coming back to. That's why all of the worker bees inside may look a little bit different, because they've got different dads from different colonies. Also, because of their very short lifespan, they tend to evolve faster. And that's why there's a lot of studies on the honeybees. They're able to track that evolution, and each generation, there's going to be slightly different genetic variations just through natural evolution. I hope I answered your question. Okay.
For several years prior to COVID, I participated in the Sonoma County bee count.
Oh.
And I'm wondering if that's still going on.
I don't know. The bee counts usually are focused on the native bees. I think not the honeybees. And I believe it used to be sponsored through Xerces, and they still do a lot of pollinator counts. They, what do they call that? The home naturalist. I forget what the program is actually called, but you can log in. Like I think there's apps for it through Cersei's, and they love when just the backyard people are reporting what they are seeing in their community, and this is how they are able to track inclines and declines in bee populations as well as the monarch population and other essential critical pollinators to our environment.
Yeah, I would like to know what royal jelly actually is and how it's produced.
I don't know. I'm just straight out tell you. They it is a gland, they produce, the worker bees produce it, the nurse bees produce it from glands in, I believe it's off of the top of their head. So they are producing it from their own bodies. They're not making it like they make honey. They produce it and then they take that and they feed that to the young larva and the queen. And it comes from the very glands within the worker bees themselves. And royal jelly is something that is harvested a lot of times for humans. They use it for various reasons. And when they do that, they are killing the queen inside. They do it intentionally for that reason. So, but it is made by the bees, and I don't know enough about it to tell you more than that.
I have a question that what you just said leads into. When I was a nurse, we used dressings that had, I guess, royal jelly in them for healing lesions, especially burns and wounds like that. And does the manufacturing of these products skew the resources available to save the bees who are vital to agriculture? And are those products, those dressings, really as valuable as we like to think they are?
I wonder, I mean, I don't doubt that they were using royal jelly. More often than not, what I hear is they're using meta honey, which is basically honey. They tend to skew more towards manuka honey, which is very strong in antibacterial and antifungal, more so than the average honey. But honey in general, it is the way they make it and they filter it through their bodies. They're filtering out all the toxins. They are actually passing it back and forth as they filter and dehydrate the nectar, storing it in the comb. It is incredibly medicinal. In general, it's medicinal. I use it personally every time I've got a cold or a sore throat. It helps me get better faster. I have used it on wounds, and I've seen people who had major wounds who were prescribed Meta honey, and the doctor was incredibly amazed by how fast he was not expecting that wound to heal as fast as it did. And since then, I don't use Meta honey itself because it's incredibly expensive, but I have put regular honey on scratches and injuries, and I have healed faster with less scarring from that injury. It does have, like I said, antibacterial tendencies, antifungal tendencies. It won't mold naturally, even in its own environment. They have found honey in ancient Egyptian tombs, 5,000 years old, and it is still perfectly good. And throughout the ages, they have used honey in trade for not just for money reasons, but to sweeten food and because it was so medicinal and critical to healing before we've gotten to modern medicine. And modern medicine is just finally taking those steps back and being like, oh yeah, they may have known something in those medieval ages of some of the natural healing ways. But honey is incredibly, incredibly healing. I have heard that with royal jelly as well, but I don't know enough about the royal jelly industry to go any deeper than that.
And our last question today, and want to remind you to bring your cups up when you're done. Our last question.
Thank you. Thanks for coming out. Is there anything I can plant in my garden that will decrease the mites?
Ooh,
To restrict the mite intrusion to the
right,
bee?
right.
Thank you.
That's a good question. I don't know 100% on that. I do know it's really good to have rosemary in your garden. It blooms a lot and the bees love it. What I have been hearing is a good deterrent to mites, potentially. The not confirmed 100% is planting thyme. They do use the oil of thyme, thymol, to help treat mites in a natural fashion. And I've heard that when bees crawl over the thyme leaves, they get some of that oil on their bodies and the mites don't like it and will fall off. That is something I've heard. I cannot verify that 100%, but it is also something that's being experimented with and seeing more and more beekeepers planting thyme around their hives with the hope that it might deter or help prevent mite infestations in their apiaries.
We'd like to thank Shannon for coming out for such a buzzingly good topic. Shannon, you just